Okay, so today we're going to be doing an example of a precipitation reaction, and we're going to find the molecular equation, ionic equation, and the net ionic equation. And we're just going to follow these few basic steps, which can be used to be applied to pretty much any type of problem where you're looking for these three equations. So here we're giving lead nitrate and potassium sulfate. And we got to figure this out. So it's important to understand what's going on. We have a lead nitrate that originally has a solid, so it's like a salt or an ionic compound, and a potassium sulfate, same scenario or situation, and we drop both of these compounds into a water solution. And because ionic compounds, they dissociate in water, meaning they separate, so they become aqueous, and that's what the aqueous means right here. So the very first step is to separate these into their individual ions. So if we look at the first one, lead and nitrate, so we're going to get lead, and because it's going to be an ion, we have to know what the charge is. And the way we figure this out, because lead is not one you can have memorized, but is bound to nitrate, which is one of the polyatomic ions you should have memorized, and you should know that's a -1. So if nitrate is -1, and we got a parentheses here, 2, so that means you have two nitrates, which is each is -1. So 2 -1s equals -2. So let's write that out. So this has to be a -2. And the lead has to cancel that out, so it must be a +2. See, very simple. Don't overcomplicate it. Alright, so this has to be +2, like we just figured out. Aqueous. Alright, plus the nitrate. Now we have 2 nitrates. And we just said that it's a negative. And we know that's 2 of them because of the 2 right here. Alright, so we separated the first one. Next is going to be 2 potassiums. You can just look at your periodic table. It's in the first column, so you know that it's going to be +1 plus SO4, and you should have that memorized. -2. But if you don't have it memorized, you can get to it the same way that we got to lead. 2 potassiums, each +1, so a total of +2. So this whole thing has to be -2. Alright, oh, forgot to put all the phases for these. Aqueous, and aqueous. I'm going to need some space, so we're going to have to get rid of those for a sec. Put that right there. Now I won't have to crunch everything together. Okay, so that was step 1. Maybe I should write this out for you guys. Okay, so here I typed out the rules for us. Step 1 is going to be separate into individual ions, which is exactly what we just did. Step 2 is to pair up the ions. Remember, this is a pretty easy step right here. I mean, all you got to do is pair up opposite charge. Now the lead, positive lead, was with the negative nitrate, so therefore you know that the positive lead is going to get with the other negative molecule in there, which is going to be the sulfate. Okay, so that's pretty easy. So all we got to do is put them together. Now, here's probably the hardest part, which isn't even hard at all. So we want to put a lead +2 with a sulfate, which is a -2. So we got to put this together to make an ionic compound for them to cancel out. Well, if we look at the charges, they're exactly the same. So they'll cancel out perfectly, so it's a 1-to-1 ratio. So it's going to be exactly that right there. See, that was pretty easy. So all you got to do is write that up at the molecular equation product. Alright? Don't put the phase yet. That's going to be step 4. We're still at step 2. So we got to pair up the other stuff that's left. If the lead got with the sulfate, that leaves the nitrate with the potassium. And once again, if you were to follow the same method, you would get, let's write it out. So we have a nitrate, let's not worry about how many we have, which is a negative, and a potassium, which is a positive. So they have, again, the same charge, so it'll just be 1-to-1 ratio. And always write the positive first. So then you just write that up there. And the molecular equation, which is the top equation, product. Okay, so that was step 2. Pair up the ions and write it as a molecular equation product. Next step is to balance. Okay, so we're going to start by balancing the top first. Alright, so we have one, oops, that's bad. We have one lead, okay, and then we have one lead here. So lead's good to go. We have 2 nitrates, only 1 nitrate, okay. So we gotta, I'll put it a different color so you know what's going on. So we have 2 on the left, therefore we need 2 on the right. Okay, but we just changed the potassium, but we'll see how it'll work out. Now we have 2 potassiums here. Now we have 2 potassiums. Okay, that's good to go. And then we have 1 sulfate and 1 sulfate. Okay, so it's balanced. Now this is one of the easier ones. We didn't really have to change anything. But sometimes if you have to change any of the coefficients of the reactants for the molecular equation, you're going to end up having to change the coefficients for the ionic equation, because these ions, remember, they were separated from this right here. Okay, so that was step 3. Now it's time for step 4, solubility table. Okay, I can't fit a solubility table on here, but all you have to do is open up your chemistry book and look at your solubility table. Hopefully your professor doesn't make you memorize it. And you look up these compounds. Why do I keep doing that? Okay, right there. You look up these compounds right here. Didn't mean to do that either. These compounds up here. So if we were to look up the lead and the sulfate, we will come to the conclusion that it will be insoluble. And insoluble means it won't stay in the liquid. If it doesn't stay in the liquid, it's going to float to the bottom as a solid. So we know this compound is a solid. Okay. Then we look up potassium nitrate, and it is going to be soluble, meaning it'll stay in the solution, so that will make it aqueous. Okay, so step 4, that was pretty easy. All we had to do was look at the solubility table. Now, for step 5, ionic equation products. Now, remember, this second one right here is ionic equation. This is molecular, this is ionic, and net ionic is going to go right below it. So, to do the ionic equation products, all you have to do, and this is real easy, you don't even need to know chemistry for this step. If you look at the molecular equation products, okay, and if it is a solid, all you have to do is copy the same exact thing you see right there. So all you got to do is copy. It's like you're cheating, but you're cheating off your own work, so it's okay. So you just got to copy it. Alright? Don't forget the solid. Okay, that was pretty easy. Now, if it's not a solid, if it's aqueous, all you have to do is write it exactly how it is in the ionic equation reactants. So copy again. So you're cheating off yourself again. So there's the nitrate, there's the potassium. All I'm going to do is I'm just going to copy that exactly how it is. Okay, so I hope I can. I'm not going to have enough room, so it's going to look weird. But plus, no, I wasn't even going to bother trying to fit it in there. Oh man, I can't even get the aqueous. Alright, there we go. And then plus the 2 potassium. Alright, hope this doesn't confuse anybody that I'm on 2 lines. I don't want the video to be ruined just because of that. But that's all I did. All I did was copy it exactly how it is. And boom, there it is. So I copy, if you look at the molecular equation, the products, if it's a solid, you copy it exactly how it is. And I put it right there. If it's aqueous, you copy it from the ionic equation part. So I took this and I put it right there. Okay, so there we go. We have the molecular equation and the ionic equation. And don't worry, I didn't forget about the net ionic. We're still going to do that. So let's make some room. Actually, we want to see the whole thing. So I'm going to put that right there. Alright, I'm not very good at using this program. I couldn't make room. But just to make it easier, I'll write the net ionic equation in blue. Okay, so I'm going to write it in this space right here. So for the very last step, which is net ionic, this is a very easy step. This is about as easy as you can get it. All you have to do is look at the ionic equation, which is going to be this one right here. Okay, and all you have to do is copy exactly how it is, except the only things you leave out are molecules that did not undergo a phase change. Okay, so for those of you who have a hard time copying, just watch carefully. So we're just going to scan through this, starting at the very beginning with lead. Lead 2 plus aqueous. Lead, aqueous. So come over here to the products. Lead, solid. Phase change. So because it underwent a phase change, I am going to write that. The lead. 2 plus. Okay. Looking good. Looking good so far. Let's keep it going. Nitrate, aqueous. Look at the products. Nitrate, aqueous. No phase change. I'm not going to write that. Okay. Potassium, aqueous. Potassium, aqueous. No phase change. Not writing that one either. Then sulfate, aqueous. Then we look at sulfate, solid. Phase change. So I'm writing that sulfate right there. SO4 2 minus. Remember, you don't even need to know what charge you're writing. I mean, all you're doing is copying it, copying your own work. All right. Then you put that yield sign, and then all you have to do is rewrite the stuff that did undergo a change. So the lead sulfate. Solid. And there you have it. Alright, I know that looks messy, but I can't erase any of the good stuff. So, just to make it look nice, let's put a little highlight through all the good stuff right here. This is your answer right here. Okay, so coming back over here, you have your molecular at the top, ionic, and then net ionic. Alright, so going back, we got a few minutes or a few seconds left in the video. We can just look at everything we did. Let's do a recap. I wrote through the rules, but we can still read that. So, all that we started off with, and I'll put a line through that as well. All that we started off with was this information right here. That right there. And from that, we got all this. I know it looks like a lot, and you're like, I don't want to do this on a test. But it's pretty easy. All you got to do is follow these steps right here. So step 1, remember we just started out with this. Step 1, separate into individual ions, which we did. Lead, nitrate, potassium, sulfate, and you found the charges through because they're ionic compounds. Go watch a previous video if you have trouble with that. Step 2 is to pair up the ions. This positive was with this negative, so this positive is going to get with the other negative, and then these two are going to get together. And then you put them together, and you write them at the molecular equation product. Alright, so we got that. We put these two together, and we got that. Next step is to balance it, and it was pretty simple. We just had to throw a 2 right there. And then the next step is solubility table. You look at the solubility table for these two that you just put together, and we found that lead sulfate was a solid, or insoluble, so it's a solid, and potassium nitrate is aqueous. And then all you had to do was write the ones that were a solid exactly how it is exactly how it was in the molecular equation product, and if it wasn't, you write exactly how it was over here. And then net ionic, all you have to do is copy the ionic equation exactly, just without the stuff that underwent a phase change. So the stuff that did undergo a phase change. And there you have your final answer. And these rules can be applied to almost any precipitation reaction.